Today's lesson will be dealing with quadratic functions. There are three learning objectives that I want to cover. One, the students will recognize quadratic equations in standard form. Two, the students will identify the major components to a quadratic graph. And three, the students will solve quadratic equations graphically. First, we need to be exposed to what's known as standard form. Standard form of a quadratic equation is written in the form y equals ax squared plus bx plus c. If you can see our examples here to the right, the first example is not a quadratic equation because the highest exponent is to the third power, and quadratic equations only go to the second power. Our second example is both a quadratic equation and it's written in standard form, where ax squared is represented by 5x squared, bx is represented by negative 4x, and c is represented by 2. Our third example, it is a quadratic equation, but at this time it's not written in standard form until we take the positive 49 to the other side of the equation, so it can be rewritten as 7x squared minus 49. Our final example, yes, it's a quadratic equation. No, it's not written in standard form until we take the 8x minus 3 to the other side of the equation. So 2x squared minus 8x plus 3 is the correct form of standard form. Now, some basic information of quadratic equations graphs. First, the parabola is a U-shaped graph that you'll get from a quadratic equation. The vertex are either the lowest or the highest points on a parabola. And the axis of symmetry cuts a parabola into two equal sections. A parabola, U-shaped graph, vertex, the lowest or highest point of the parabola, and the axis of symmetry cuts it in half. Now, the solutions to a quadratic equation are represented by what's known as the x-intercepts, or the roots. In this case, this graph crosses the x-axis two places, at positive 2 and negative 2. So those will be the solutions to this quadratic equation. X-intercept being defined as the ordered pair where the graph crosses the x-axis. Roots is another name for solution. Now, in an equation like this, y equals 3x squared plus 4, a quadratic equation, the parabola opens up. The vertex is the lowest point on the graph found right there. A situation like this where a, or your leading coefficient, is negative, the parabola opens down, and the vertex is the highest point on the graph. Now, when we want to graph a quadratic function, the following procedures need to take place. First, our equation is y equals x squared minus 2x minus 3. Our input, or our x values, are already given to us. In this case, they are 0, 1, 2, and 3. Then we need to calculate our y value by either using a calculator or by hand, computing the expression. 0 squared minus 2 times 0 minus 3 gives you a y value of negative 3. You have an ordered pair. Finally, you graph your set of ordered pairs, and you find out all the key elements to the graph. The x-intercepts, or your solutions, the vertex, and your line of symmetry. Here's another example. Same procedures. You insert your x values into your equation, calculate your y values. Then you have an ordered pair that you simply graph. So quadratic equations are not very hard. The procedures are the same with both linear equations, exponential equations. You're given input values, you calculate output values, you're given ordered pairs that you must graph. Thank you for listening to my explanation on quadratic equations.